Okay, so this is life cycle costing exercise 3, a continuation of exercise 1 and exercise 2. In fact, very similar to both those exercises. A little bit different than exercise 2 because we're back to calculating the life cycle costs kind of horizontally here rather than exercise 2, which was vertically. Another difference is that we've got 3 separate sheets for our real costs, our nominal costs, and our present value costs. Real being in today's money. So you can see we've got electricity costs here at €2,500 every single year over the course of a 40-year study period. So if you just click to the side there, you see it ends at 40 years. We've also got some door repairs. Now this is a simple exercise with just 2 items. Maybe in a real life cycle cost scenario we could have quite a few. But for just getting used to the calculations, we'll just deal with 2 for the moment. Doors repair are at irregular intervals. So we've got something going on in year 4. It could be repainting the door, doing that again in year 8. Then maybe it's replacing the door completely in year 10, and then starting the cycle of repainting in 12 and 16 every 4 years, so to speak, throughout that 4-year period. It doesn't really matter about the actual costs. We're just getting used to the calculations. But in terms of real costs, it's quite straightforward. It's today's money. So what we'll do is we'll sum those 2 costs in terms of their total. The total formula is already in there. You'll sum the 2 totals to get your overall total, and then sum the total lines for each column to get your total costs in each year. Then move on to your nominal costs. Your nominal costs, and I've highlighted in blue there, it's the exact same sheet really, except we're going to calculate a factor in here. Now the factor is going to be our escalation factor per year. So it's the same formula. Go back and maybe look at some of your tutorials there. I think it's equals 1 plus I to the power of n. And this formula is essentially a compound interest formula that will calculate a factor in every cell throughout that 40-year period that can be applied to, if you click back on the real costs, that can be applied to the real costs. Okay, and moving on from that, then we've got the present value costs. That'll be similar. We'll have to calculate a factor in there, but this time it's a discount factor. So again, look back, and that discount factor will be different because you'll be applying a different year every year for that 40-year period. So it'll probably discount back from what is close to 1, and it'll decrease over the period of time to 40 years. So then what you'll do is you'll multiply that factor by the nominal cost. So the way it's working is essentially we're increasing our costs through an escalation rate of 2.25% from year to year. And then we're discounting those nominal costs back with a discount rate that we'll calculate below the line here and apply again to our electricity costs and our doors repairs of our nominal costs. So we'll have 3 costs representing life cycle costs. We'll have the real costs in today's money. We'll have the nominal costs in, future costs, escalated costs, and we'll have the present value discounted costs, all depending on what's going on here in escalation rate and discount rates. Now I want you to do it in such a way that you, lock cells and link sheets so that if one item changes, if I, for example, changed any one of those items there, it would change across all 3 sheets. So if you give that a go, and then maybe once you've finished, without peeking, obviously, you can have a look at the solution I put up on Brightspace. And if you've got any questions after that, by all means, send me an email, or we can have a little chat on Bongo or MS Teams and work out the solution for you. But ultimately, this is what you've done over the last 2 exercises. I'm just leaving it up to yourselves to do a little bit more work on your own rather than following exactly what I've done on the screen. So thanks for that.